For learning how to do parallel circuits, I'm going to have you first get started with Explore Learning. So you'll be completing activity 3-1. It's just a circuits activity. I'll need to open up a tab and I will type in Explore Learning. And from here, right, if I kind of toggle back and forth, I can type in, I want to log in. So I'm going to log in with a username and password. So my login, right, so this already has me logged in. So let me log out and let me log back in. And my username and password, Go Warriors 10, Go Warriors 10, and my password is DHS 2010. Now, this is going to be our science. Notice I'm scrolling down. There's several science teachers that use this. And I'm going to get to this one here. We have what's called Circuit Builder and Circuits. I need you to click on Circuits. Now, you could jump right into this by launching Gizmo, and that's fine. But I'm going to take you the long way just to kind of show you the steps. You can always launch the gizmo. The gizmo is this activity. This is the activity that you need to work from. The gizmo is simply the program that you're going to be working from to use the circuits themselves. Now, we should have at least had a little bit of practice doing this. So I'm going to start building a circuit here. And the circuit I begin to build, so notice I'm going to separate my tabs. This circuit I'm going to begin to build here is going to be based on what I had you doing over here. So the first thing I have you learn are what are multimeters. And I need to start off by building, let's just say, I'm going to start off with a series circuit. So my series circuit, right, a series circuit, I've got one path for current to travel. I'll just put a battery in here. Doesn't really matter. I've got a switch here, and I have my bulb should come on. And here my bulb comes on. And I can modify the voltage. Notice if I'm looking down here, I can modify the voltage. It goes all the way to 50. Well, 50 here, and it goes all the way down to 1. But I want you working with a 10 volt. The 10 volt is just kind of the easiest way to work from it. I can show current, right? Conventional current says cathode to anode. In this case, it'd be counterclockwise. I can show electron flow. That's going to be anode to cathode, and that would be my that would be clockwise, right? If I open up the switch, open the switch, breaks the circuit, I can turn it back on. And I don't need these for now. So let's complete the handout. A handout here is based on this first drawing. So if I'm going to calculate, so complete. So what is a voltmeter? Well, a voltmeter is going to tell me how much voltage is being pushed by the battery itself. Now, it's nice because here it's given, and that's fine. You can always use that. But you won't always have this value given. So if I have my cathode, positive end, negative side anode, you'll see that the readouts, so here are my meters. These are what I'm measuring. The voltmeter is 9.9, actually this would be repeating. So 10 volts, we'll call that 10 volts. It's a 10 volt battery. And sometimes your numbers aren't going to be perfect. And it's 10 volts is the voltage that I started off. And I could modify that if I wanted to, but I'm not going to. Second part, current. Notice that the current here is going to be 0.67 amps. It doesn't matter where I put the ammeter. It's 0.67 amps everywhere in the circuit. Now I'm referring you to look at the measure out, the readout here of the ammeter itself. And it doesn't matter where I put the ammeter, it's going to measure this. And then last but never least, for measuring resistance. For measuring resistance, kind of a tricky play because you have to break it. You have to separate the circuit to measure the resistance. So an ohm meter, just what it sounds like, it's a measuring resistance. And each light bulb is 15 ohms of resistance. So you'll see that as I measure the values here, I had a 10 volt battery, I had 15 ohm resistor, and I have 0.67 amps of current. And if you did the calculations according to Ohm's law, you would find that, well, that's the way it should be. Those are the values that you should get. So I cleared off my circuit here. So now I'm going to move on. I'm going to move on and complete the bottom part. If I'm going to build branches, it says 2 branches, 2 10 volt batteries in sequence, and branch 1 has a 1 bulb resistor, 1 bulb, and branch 2 has 2 bulbs. And I can do these fairly quickly. I just want to make sure you realize that you're clicking and dragging, you're just pulling a bunch of stuff over, and let's see, I need 1 bulb in one branch, and I need 2 bulbs in another branch, and I don't need these many branches, so I'm going to go ahead and start using these over here. And I've got another bulb, and I needed 2 10 volt batteries that are pushing current. And let's see, a couple wires. A couple wires should complete it. And my lights should come on. So, branches. Branch 1 has 1 bulb, branch 2 has 2. So now I need to apply using current. Find current across each branch, and then the total current. And then I'm going to find the voltage drop across each branch, and then across each resistor. So let's do number 4 first. So the current, I'm using my ammeter. Notice my current across branch 1, I have 20 total volts divided by 15 ohms of resistance. It's going to be 1.3 amps of current. So branch 1 has 1.3 amps of current. Branch 2 is going to have 0.67 amps of current. Now, anywhere along this branch is going to have 0.67 amps of current. But remember, if I have 0.67 or 0.7, right, we round to the nearest tenths in here, 0.7 plus 1.3 tells me I should have 2 amps of total current that are leaving and returning to the batteries. The reason why I'm calling this total current is because the total current incorporates or adds together branch 1 current, where I can apply Ohm's law, and branch 2 current, where I can apply Ohm's law. I think the importance here is that you ignore the other branches in parallel and just treat each branch like it's a series circuit, and then add them at the end. If I solve for, next part, voltage drop across each branch, I've got 2 branches, and then across each resistor. You will find voltage, okay? Voltage across, let's go branch 1. Branch 1 here, branch 1 is right here, right? 19.96 volts, okay? Well, 20 volts. And if I move this over here, you'll find that I also have 19.6 volts of current. So each branch gets 20 total volts. However, when I only have 1 resistor, the voltage drop across this resistor is 20 volts. So branch 1 is getting 20 total volts. This bulb here is going to be brighter than these over here. And here's why. Because the voltage drop across each bulb. Think of it this way. If I have 20 volts across the entire branch, but I have 2 resistors, each resistor is going to have a 10 volt drop across it. So I've got 10 volts here, right? 20 total. I'm referring to this value here. And I've got 10 volts here. 10 volts over this one. So 10 volt drop over this bulb and 10 volt drop over this bulb is 20 total volts across this branch. And that is a good place to stop.